Hello students, how are you all? Today I will talk about a very favorite reaction of any competitive exam, or we can say board exam, right? We are talking about Cannizaro reaction. It is in the aldehyde, ketone and carboxylic acid chapter of class 12th, right? Of organic chemistry, okay? So means that in Cannizaro reaction we need to just identify the conditions, right, of reagent, and means reagent will be given base and it will be concentrated, right? Okay, and that your carbonyl compound should not have any alpha hydrogen, right? Okay, so I have written a aldehyde which is formaldehyde, right, which do not have any alpha hydrogen. Okay, so if I give basic condition, concentrated basic condition to formaldehyde, the product will be will be methanol plus one will be the salt of carboxylic acid. Okay, so we will try to identify the mechanism behind the reaction, right? Okay, so let's go. Okay, first of all, the base, as we all know, what is the difference between base and nucleophile, right? Base generally abstract proton and nucleophile generally attacks to an electrophilic center. Okay, as you all can see here that there is no acidic proton in formaldehyde. So what does this OH minus will do? This will act as a nucleophile and it will attack on electrophilic center. Okay, so as we all know, in carbonyl compounds the electrophilic center is carbon, due to the difference between electronegativity between carbon and oxygen. Okay, so this will attack on electrophilic center and this will goes up. Okay, H O minus and OH and H. Okay, then this, as you all know, negative charges are not stable. Then what does it will do? This will make a bond again and H minus will leave. So our first product will be HCO OH plus H minus. Okay, as we all know that our first product is formic acid and hydride ion, right? As we all know, hydride ion is very nucleophilic in nature, so it will look for another aldehyde molecule so that it can attack at same electrophilic center. Okay, so we'll try to identify that. Okay, so here we are taking another molecule of formaldehyde and this hydride ion will attack on electrophilic center, same. This O minus and H and H, or we can say CH3O minus, right? Okay, and here I'll tell you a point, right? As we all know that in our medium formic acid is already present, right? Okay, so I am writing here formic acid. Okay, as we all know that in these acid base reaction will occur. Why this will happen? As we all can see, this minus will attack on H, so it will give acid base reaction, right? So CH3OH plus HCOO minus. This occurred due to the stability of negative charge due to resonance. Okay, so this negative charge is more stable in the salt of formic acid as compared to that CS3O minus. Okay, so this is a generalized mechanism of Cannizaro reaction. So we will take another example of this reaction. I am taking an example of benzaldehyde, right? So concentrated OH minus. As you all can see that there is no alpha hydrogen in benzaldehyde. As you all know that this is benzaldehyde. So same process will occur. I am writing only products. Okay. CH2OH plus COO minus. This is an alcohol and this is a salt of carboxylic acid. Means suppose if I have taken KOH, right, then it will be K plus, right? Okay. So this is a general reaction. Now, as you know that one molecule is undergoing oxidation and reduction itself, right? So Cannizaro reaction, if one molecule is reacting, then it is a disproportionation reaction, but sometimes it may not, because it depends upon the molecule to molecule. Okay, so I will take a very good example of this, right? So I will rub this on. Okay, now I am taking an example, a very good example of Cannizaro reaction, which is intramolecular Cannizaro, right? Okay, same basic condition is given, concentrated, right? So same process will occur. This will go, and this will come again, and this hydride will attack, and this H minus will attack on same, and like this, right? So I am making the products only, right? Here, okay, COO minus, and here CH2OH. Okay, this reaction occurred in same molecule, right? So one part is oxidized and one part is reduced, right? Okay, so like this means many cases are possible. So we'll take another many examples, right? Okay, so thank you.